and welcome to Chemistry 101. Today we will be covering atomic mass and atomic number. What people fail to realize is that the periodic table holds a lot of valuable information concerning an element. It can hold information such as the number of electrons, neutrons, and protons. Now, if you will please take out your periodic table, we will start getting into some examples. If you will look on the board, you would see the symbol, the element beryllium. On your periodic table, it is in group 2A, period 2. We will start with the basic parts of an element. The top number, which is number 4, is the atomic number. The middle symbol, abbreviation, is the symbol for the element, and the bottom number, which is usually a decimal, is the atomic mass. Now Harold will go into deeper depth on how to figure out the valuable information I just told you about.
And welcome again to Chemistry 101. As Aviance mentioned earlier, the periodic table holds a lot of valuable information. Now we will take a deeper look into the basic makeup of an element, and the example that I'm going to use is the element beryllium. The atomic number, which is usually known as the number of protons, also equals the number of electrons that the element has. The Be, which is the symbol or abbreviation for the element, and then the atomic mass, which for the element beryllium is 9.012. If you average that, it equals 9, and 9 is the number of protons and the number of neutrons. If you were to figure out how many neutrons were in this element, you would simply take 9 and subtract 4 from 9, which would give you 5. And that is the number of neutrons, and 5 is the number of neutrons, and 4 is the number of protons in the atomic mass, which makes up the nucleus of the atom. Now we'll draw the atomic model for the element beryllium. If you take a look with me at the model that I've drawn, you will see here, as I have labeled it in the key on the side, squares are the neutrons, triangles are the protons, and the dots with a line through them are the electrons. As I've already stated, beryllium has 4 electrons and protons and 5 neutrons. I've drawn 4 triangles here, which are the protons, and 5 squares here, which are the neutrons. In the 2 outer rings, because the first ring can only hold 2 electrons at a time, it has the 2 electrons that needs to go there for beryllium, and then I drew a second ring which has the other 2 electrons in it as well, which add up to 4 electrons. And this is how you draw the atomic model for beryllium. And now back to you, Aviance.
Welcome back, everybody, and to sum up what Harold said, I have drawn a chart where we can review some more elements. Remember, you can also use your periodic table when answering these questions. Okay, so now we go on to the number of protons. As we mentioned earlier, the number of protons equals the atomic number. So you would look at F on your periodic table, and F is in the group 17A and period 2. That answer would be 9, since the atomic number is 9. The number of electrons also equals 9, since protons equals electrons. And when looking at the number of neutrons, as we mentioned earlier, you would look at the atomic mass, which is 18.99, and you would subtract the number of protons from that. And since we have 18.99, we would automatically round that to 19. So 19 minus 9 equals 10, and that's the number of neutrons. The next element is chlorine. Chlorine is also in group 17A, but it is in period 3. Chlorine, the chemical symbol for that is obviously Cl. But the number of protons is different from fluorine, and that's because the atomic number is 17. And again, the number of electrons also equals 17. Now we look at the atomic mass. And that is just some elements that you can practice this method with. Back to you, Harold.
Hello, guys. Lastly, I will give you guys a critical thinking question, and the answer will be displayed in the credits of this video. The question is to examine elements thorium and protactinium. Compare their atomic masses and the number of proton, or their atomic number that is shown above the element. while comparing these, why does protactinium have a lower atomic mass than thorium? Think about it, write your answer down, and you will see the answer given in the credits. Thank you.